All right. Anybody, it's got audio.
I see video. You actually don't have any video on the screen here at the moment.
No, I have it disconnected.
But I see video. Say
right.
something.
Cool.
Okay, yes, we've got, I can see and hear from somebody who's not in class.
Okay.
So.
Cool. All right, so where were we? All the answers. I am kind of, in some ways.
I can't be wrong.
Where are we at? Yeah, we're talking about static classes. Can hear it. Yeah. Yes, 42. All right. So everybody gets the access modifiers, understands what that's doing, right? Oh, there's quite a delay. Unless somebody had paused that. I just heard my voice. All right, cool. So then by default, your declarations are private. So you can't access that from, oh my gosh, this pad, here we go. Because my double and my float, even though I didn't declare it as private, it is. I tend to declare all my access levels regardless of what's implied, just to make sure that it's clear. And most of the time you'll want them, especially your variables. Most of the time you'll want them to be private or protected in some way, because if you allow them to just be public most of the time, then yeah, it should be. It's sharing. It says screen sharing is presenting to everyone. Hey, look who that is. Present to everyone. Ha, 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 ha. All right, how about now? Is there screen? Can you see it?
There it is.
All right, cool. All right. So again, where were we? Oh, private, yeah. So if you don't make this private, then anybody can change that value of that variable. So if you leave this as, and there are some times when you want that to happen, but most of the time you don't want your internal information to be messed with from an external source without you acting as a gatekeeper in some way. So if you leave this as public, then when I instantiate this here, I can just say c.myFloat equals, I don't know, 25.0, whatever. But if the information inside of this class relies on the value of my float, then you have no way of knowing that that's changed and that you need to modify anything else. So if you had another, and again, these are not practical examples necessarily, but it's just showing the relationship. So let's say that my double you always want to be twice the amount of my float. So right now it is twice the amount, 0 and 0. If you had this set to public and someone changes that up here, now it's 25, but my double is not 50 as it should be, because your class was designed to always have my double twice the amount of my float. So one way that you could do it is simply make these private. and define your own getter and setter methods down here. There's another way to do this that we'll go over in a second, but you can do, make this method, and actually we could make that, we'll leave it void, it doesn't matter. Set my float value. And now you're controlling the flow, setting it, but you still can't get it because it's set to private. So make another one, public void, get my float, earn my float. And then in here, oops, that's not void. And then in here, we just simply say my float equals value, and then you say my double equals value times 2. But then anytime, because the only thing they have access to up here, this is now aired out because that's private. You can't access that internal variable, but you can get set my float and get my float. So if you do set my float 25, then when you come down here, when that executes, set my float is going to execute. My float will become 25, and my double will become value times 2. So again, this all depends on the purpose of your class and how you're using the information in it. And that'll tell you whether you need to take these steps or not. Chances are you probably will. So there's a bunch of other ways to do this. I'm just going to delete all this. Does everybody, actually, I'll leave that in there. I'll make another one. We have another one, and we'll actually just do, now it's a property. We have getter and setter methods for this. So this is going to say I can simplify it. Naming rule. Oh, naming rule. No. There we go.
So how will that work again?
Why is this telling me that it's a naming word? What? What?
Trying to figure out how the method.
It's not a method, it's a property. So it's just get and set. It works like any other float. But we can now customize these. So we can say my float 2. So if we come up here, oops, I didn't want to make that private. I want that public. If we come up here, you can say, you can see that my float 2 is accessible from outside of that class. But if we wanted to control, like we were on the other one, we want to control the flow of things. What happens when we do what? We can define these. So we could say public get. Oops. And this is I wrote this all wrong because I started it in the middle. Now I forgot where I was. Actually, I don't remember whether I need to come up there or not. Yeah, there we go. Okay, there we go. All right, so now this is a property. And then we have, and actually, double. So now this is effectively doing the same thing as the set my float and get my float. Except it's now using it in terms of a property. So you treat it just like a variable. So with this one, if we said my float 2 equals 25.0f, that's effectively doing the same thing. So you assign it and you refer to it the exact same way you would in any other as any other variable.
Basically, it's just a shortcut to encapsulate.
Exactly. So it makes it very easy to write very cool things, because then you can also just do this. So we can say private get, and then if we tried to look at this, oh my gosh. Wow, there we go. All right. You look at this, we can see that it even says private get and set. So we can't read the value, but we can set the value anytime we want. And the access modifiers are the same there too. You can set this to protected, which means that, again, any internal or any derived class can actually call the same get method. If you make it protected, it's only available to the base class. Or excuse me, if you make it private, it's only available to the base class. And then you can also say read only. Why am I having a hard time remembering what that is? Or maybe they removed that in the newest version. You can set it to read only, basically, so that it can be initialized only when the class is set, and anytime after that, it's stuck at its value.
Just got something going on.
Oh, it's right here. My bad. I did that. It's not on the getter and setter. Another. So this one can only be set at instantiation of that class, and then after that, you can only read it. So when you instantiate the class, this is totally valid if you say float some float, and then my float 2 equals some float. I know I got the caps wrong. That's valid, but if you come down here, float, if you give me an error and say that it's read only, it can only be set during the initialization of that class or that object. Does everybody understand what the read only did? Yeah, makes it read only. You can set it once. And all right, let me undo that and get those getter and setter back in there. All right, so Ike, you had a question?
I'll make sure I understand what's going on. So, line 13, basically saying that basically assigning the 5.0 to the value on line 29.
Well, it gets passed to the setter method with the as the variable value, yes. So this syntax calls this function or this method down here and passes it a variable called method or value. Basically, is what's happening.
It's the text feels a little bit like struggling a little bit with it. It's not like the rest of C# from what I've seen, but instead, gotta define might have like a parentheses with value.
Right. Yeah, because this is specific to property definitions. So these are considered fields. This is considered a property. If you, I'm trying to think of maybe something that would help.
So the value literally smartly.
Well, this one just says that that's a valid variable for this particular method that's being called. Yeah. This is how I typically do it when I have this. I usually have an internal variable, private float. Usually use an underscore to make sure that I know that that's what I use. I don't particularly like underscores, but in this case, it allows me to name it the same thing. So I can say, and then I have a public version of that. with my get, which simply returns, oops. So prop float is basically underscore prop float is acting as my just my holder. It's the thing that stores it, and it's not accessible. You can't manipulate it at all from outside. And then set simply let me indent that one too. So this is really good when you want to be able to interact with something as you would any other field in that class. You don't want to treat it like a function or a method. So you want to interact with it like you would any other field, but you want it to have maybe some secondary effects when they set those values. Because in this case, we could do what we're doing here and change the value of any other property or field based on this one changing. So if you had, like, let's say, actually, here's a good one. Let's say that this is actually supposed to be representing a percentage, and you want to treat it like an integer. So you have 0 to 100, right? Zero to 100 real quick. So if we go percent, then we can say underscore return percent. And then in here, we just want to get our internal value. But in here, you want to say, let's say that you want to cap this to 0 to 100. If value is greater than or equal to, oops, 0 and value is less than or equal to 100, then percent equals value. Otherwise, nothing happens. You don't have to set that value to anything. So this gets called, and now you have control over the value range within this variable that you stored. So you can access percent anywhere out here, and you can try and set it to 250, but it'll just deny you, and it'll stay at whatever its current value is. We could write a console app to do that real quick if you guys want, but do you want to see it in action? Would that help?
Yeah, because right now it has no value.
No, it's 0. Default value of an integer is 0 when you declare it, so it's 0. So if we said, I'll just do var for that, make it easier. Yeah. What was I doing? C. Say what you entered num and c dot percent. If a read line, cool. So enter a number 5. You enter a number, percent equals 5. 25% equals 25. 150% still equals 25. That's really all it's doing, is it's just allowing you to take action on the set or get, because maybe you actually just want a get for percent that doesn't actually have anything to do with an actual value stored anywhere. It's a calculated value. So we could say right here, public float percentage. This is a really terrible naming scheme, but, and then we just want to do a get, and it simply returns underscore percent, or you could even use percent, it doesn't matter. Percent divided by 100. And then we can say percentage to, and then c dot percent. Something. Percentage. All right, so now 5, and we didn't treat that, and we didn't get it like we would a method. We didn't call it like we would a method. We just simply said c dot. This thing is so. Oh my gosh, let me scroll. There we go. Can figure out where the heck I was. So we're not treating either one of these like methods, but both of them have secondary actions that occur when you either get or set them. So properties can be very helpful because you have access to the getters and setters. Again, you can do the same thing with defining them in methods. It all depends on how you want to do it. It really depends on, for me, it depends if it's a really simple thing that's going to just take 2 lines to accomplish, and I just want some secondary action when one of these things happen, I put it in a property. If it's going to be a lot more complicated, then I'll put it in a method itself. Just because if you start writing these and they're huge, they start to become very convoluted. Just because of the way that they're so nested inside there. But everybody understand what's going on there, right? So if we say 150, it's greater than 100. 101, it's greater than 100. Everything stays the same, so it caps it. So it's anywhere between 0 and 100 is perfectly fine. But if we say -1, it stays. If we say, actually, did that parse that to 1? No. Yeah, okay, it stayed at 100. And then if we say 101, it stays.
Was that just so that stuff later on, but have access to greater everybody?
Yeah, it's because these don't actually store anything. This has no value. This has a getter and setter method associated with it. So you need some place to store that value. Cool. See if I'm missing anything. Pretty sure that was pretty much all of it. Oh, yeah. We do want to go over constructors. Everybody understands constructor, though, right? I mean, we've gone over this before. You know how constructors work. Anybody have any confusion on constructors or how they work? It's okay to admit it if you do. So there are a few things that we need to go over with them, but everybody's got a good basic idea. So if we have this class here, now we have this constructor, we can also define, oops, I'm running this still. We can also define another constructor that accepts a float, not flags attribute, float, a float. And then we can say my float, this dot my float. Everybody gets this too, right? If not, I can go over that next. Yep. All right, so this is just going to pass in a float, and then it's going to set this my float to whatever you passed. So if we come down here and we say, let's say we have another one up here. Private, oops, make that public for the sake of demonstration. I'll call this in float. And then we have another class, new class, that accepts actually, I'll name these what they are. My float, float, and then I need to make that protected. Actually, no, that's a perfect example. All right, so let's say that you want to set the my float in the parent class because some other calculation is inherent or is part of it. You could either say well, let's get rid of this. New class. New class. Oops, I did not format that so it's easily read. All right, so we have a second constructor here that sets one of its own variables. You pass two parameters into it, my float and inner float, but you don't have access directly to my float, so you have to call the function, or the method rather. And then you call the inner float here to set that one, right? So if we pass it 25 and 10, you can see that it ends up being 25 and 10. But another way to do that, since your parent class is already doing this with this base class, or this base constructor right here, you can simply say, we can get rid of that. And say base my float. And now when we run it, we have the exact same result. Because, like, let's say that the constructor does some things in the parent based on the number of parameters or something like that. You can call your base constructors just by chaining it with the colon between your constructor and the base constructor. So mine takes 2 parameters, but I'm telling that even though mine takes 2, just go ahead and call the base with 1 parameter so that it can do what it needs to do with that 1 parameter. Oh, I just did this dot set my float. I just called the function, or the method rather, that sets that value.
And because it is set private, you have to create an object.
You always have to create an object of the class to set it unless it's defined as static. Or you have to create an instance of the class in order to define an object, or in order to define the value. Static and const are the only 2 that are not like that. Const you can't write to. So the only difference between this is I'm writing it here saying I want to explicitly do this action in my constructor. If I do it this way, I'm saying, Jesus, take the wheel. I'm saying I trust the base, my superclass, my parent class, whatever you want to call it, to know how to handle this constructor and do what it needs to do because I'm inheriting it from it, and I don't want to mess anything up or interfere with anything that it's doing in its constructors. So I want to add my own constructor, but I want to keep everything that it does normally in its constructor intact. So I'm calling it instead. Because I might think I know what it's doing, but maybe I don't. Maybe I don't have all of the details of everything that it's doing during its constructor. So it's often better to rely on the parent or the base class, unless you want to override the behavior entirely, which is sometimes true. But if you don't, then it's better to rely on their constructor since they're the ones that wrote it, unless you wrote it. But then again, you know what your use case is. So it all depends. So everybody understands the constructor. You can have multiple constructors that take multiple number of parameters that do different things depending on which one you're using when you use the new keyword, right? Cool. So then the difference between static and const, everybody got that right? Static is accessible at any time, can only be instantiated once, and you can read and write to it. Const basically is a read-only version of that. So it sets the value once when it starts the program and leaves it at that. You can't write to it, but you can read from it. Cool. Let's see. That's pretty much it, really. What's that? The read-only keyword? Yeah, that's the one that I was talking about with here. Earlier when we did the so this one, because it's read-only, it's marked read-only. In the instantiation, you can say summing equals 5, but you can't access it anytime after that. No, you can access it. That's correct. You can access it. You can't modify it. So you can modify it during instantiation, and that's it. So if it's read-only, you set it, and then it's done. But that's not the same as a const. A const is always there, just like a static is, but a const is read-only. So in this case, this value is set at instantiation. So if I set in here, for instance, let's say I had another parameter, then I could say this dot myInt equals this dot SumInt equals SumInt. I don't know what that value is. It's going to be determined when somebody instantiates that object, right? So this can be set once. A const is defined when you write it in code, and it stays that way. So if you say const some const int equals, that's defined right now. That will never change. It will always be there. You can't define that in a constructor or anything like that. That's the value it has. That's the value it always will have until you change it in the code and recompile it. So that's the big difference. Is read-only is a field or property that's in no, is it property? Yeah, it's a field, not a property. It's a field within an instantiated object that is set at instantiation. A const is defined from the start and stays that way. That's how I've always done it, because it makes it very clear that that's a constant. And so when you're reading through your code and you see it, it stands out. Yes. It could be any number of things. I often use it if you're using, like, let's say that you have network communication between two different things. Actually, it really doesn't matter. It could be flags or any number of things. But let's say you have messages being sent back and forth. Yes, exactly. So you have certain events that are sent in that message. Like, let's say you're looking for a specific string. Those strings are never changed. It's part of your protocol. So you can define those in constants and then just use those constants as reference for what key is what action or something like that. So you could send a message that says blah, blah, blah. And then since that string, or let's say you have a string that says, I don't know, print current value, who knows? But you store that string in a constant. And then whenever you receive a message over the network, then you can just say, look at this key, print constant value or print whatever. And it will match that and say, oh, okay, that's in there. And that never changes. That's always going to be the same, unless obviously your protocol changes and you need to decide that you're going to use a different key for a specific action. Yeah. Anytime that you want to be able to just make sure that the data is consistent from start to finish, const is a good idea. If it is never going to change and it's going to be used frequently, then make it a const. That's pretty much it for today. Oh yeah, somebody wanted me to go over the this keyword. This is like self in Python. It just refers to the instantiated object that it resides in. So if you say this.SumFloat, it just means my instantiation.SumFloat. That's why these are different scopes. If you look at that, it highlights this. My float by itself will look initially in the local scope, which in this case is that particular method, this constructor. If you say this, then you're saying look at my instantiated object, not the current scope. So if you say this, notice it highlights down here. I don't know why I pointed at my screen. You can't see that. And it highlights up here. I'm referring to my class, my objects, my instantiated objects variable. Cool. All right. I'm good then, unless anybody else has anything else. Mm-hmm. Yeah, I guess we don't have a lot of TFs here, do we? How many TFs do we have? Oh, we have 3. That's it. Yeah, 3 out of, yeah. What did you, let's see, it's 7:20. I want to make sure people have time to actually do this. Hangouts, where work happens. Yeah, okay. So what was the... Oh, okay. Oh, you wanted this one. Mm-hmm. Okay. Oh, okay. Gotcha. Let's see. That one was. Am I running that? No. Okay. So it's talking about this right here, right? They want you to define your own cheese object. Mm-hmm. Okay. All right. So let's add. Actually, let me follow their guidance to make sure that I don't confuse anyone here. You want to create a new folder at the same level? Yep. Within, create a cheese class and description, name and description. All right, cool. So we'll create new item. I'm just going to call this, actually, yeah, let's just call it a class and we'll call this cheese.cs. All right, so we have our cheese class. And this has two fields, name. What's that? What do you mean? Mm-hmm.
You should always first declare fields and then property. Then you just declare the property and set name, get name, set name, and the property description, set description, get description, set description. Because so that sometimes people just skip the part of declaring fields, they just declare the property itself.
Yeah, if you're just declaring it with a get set, are you talking about with the with that? Yeah, if you just do that and don't define a body in either one of these, then it works fine. Well, the other one is if you want control over what happens in the getter and setter, or whether you don't. Well, yeah, I mean, if you want to take action when it's set, then you would define a body under the set. If you want to take action under get, then you would define a body under get. I mean, if you just want to use it like any other standard property with no extra actions when you set or get, then this is fine. But the difference is it sets it, or it creates the getter and setter here for the description. And I honestly would have to do a bit more to give you a more in-depth explanation as to why properties are different than fields.
Because you can access already. That's mostly private. Private is, again, it's the way how you can access, that's what you need them for inside the value.
Yeah. I mean, you can define this as saying private. I mean, that's what I was referring to earlier. If you want to take action and handle how that data is manipulated during the get and set, then you define the body. But you can also do this and say that you can only set it but not get it. Or you can say private set so that it's so that you can't set it but you can get it, except for internally. But other than that, the more fundamental difference between the property and the field, or why you would choose one over the other, I wouldn't be able to tell you from like a compilation standpoint. No, because you can do, this is perfectly valid actually, especially for what we're doing right now. We can define these as fields and it doesn't matter. Yeah, as long as it's public, you can access those outside. Right. That's what I was doing earlier.
But it's valid, but is it as practice to have your fields be private and make these accessors?
Yeah, they were pretty pretty adamant on making everything private. So there's ways of thinking about it, but there's not really like one way of approaching the problem, because it really doesn't matter if your application doesn't require that that data is protected in any way. I mean, it doesn't really matter. It's really depending on how your class is going to be used. I mean, there's tons of times when I just make a field public because it needs to be manipulated by some outside source. But there's also tons of times when I use the others because they don't need to be in, they should be protected. I mean, it all depends on how you're using it. But yeah, I mean, you could use a property or a field right here. We're not doing anything that's dependent on a property at this point. And even if we decided to make it a property later, the way that you interact with it doesn't change. So at any time, you could just change the code and make it a property instead of a field. So obviously, the only thing that would cause a problem is if you do any sort of assigning outside and you decide to make the setter private, then obviously you're going to have issues. But that's like with any refactoring, though. So if you can define these with get and set and make them properties, that works. Or you can define them as fields and they'll work just the same. So if we did this, this is how I would have approached the. So here's my simple class. Did you understand what I was saying though? I mean, did you have any other questions that didn't get answered, or do you feel like you're pretty clear on that? Okay. Cool. Well, if you have any pointed questions, then like if anything else comes up, feel free to ask. All right, so here's the example controller. Let's make sure that this was in example.gs. Okay, cool. So this created its own namespace because it's in its new folder. So we'll say using cheese. That's my namespace. Gonna get confusing. Let's change that. Make that custom. It's the exercise that you asked about. So I created a file. I created a folder called cheese, which was probably not the smartest name because I have a class under it called cheese. But so then I define a class that has a name and a description, and then it has a constructor that accepts a name and a description, and then it assigns those two in the constructor. And I set the namespace to example.custom. We could actually just get rid of that and just make this example. So then it's just available by default and it won't matter. So we can get rid of that. So there we have our cheese and cheese. So we're going to be holding the cheese object in our list. Obviously, this is going to error out because this is no longer valid. And this needs a description. So then now we instantiate our new one and then add that to our cheese. We could just put this new cheese name description inside of this add, but for clarity, we'll just define it outside. So we instantiate a new cheese using the name and description that's submitted, and then add that to our list here. And then in our, in our view, not home, example, add. So in here, we need to add another input. This is going to be description. I don't have label. I'll add a label here. Label. Name. Label. Description. So now we have our form that has two input fields, one for the name and one for the description. Name, named name, and name, and description, named description. So when those are submitted, they'll submit to the controller and pass name and description, which will then be used here to get added there. Everybody follow along so far for anybody that was confused about this particular exercise? So then in here, we're still adding this to cheeses. So when we go to our index to view, instead of just viewing the cheese here, it'll be cheese dot name, cheese dot description. And then we can actually put this, let's wrap that in something else. Just put, I don't know. There. Make a little bit of a distinction. And tab that over, tab that over. That's as long as I didn't make any errors, everything should be good. So name. Who cares? Oh well, several typos. Who cares? Okay, there we go. Oh yeah, it's because I declared it as a list string in there. I need to change that. So this is in the view. Oh, dang it, I didn't need to do that. Okay. Oh, I still have that in there. Hang on. Talked about this at the end of class and I changed a couple of things. View data and view bag. Data. Simplicity's sake. Next, let's get rid of the view data one. So there. Now we have cheese one description, add another one, cheese two, another typo, who cares? Description. And now we have a list of our cheeses based on objects, particular class called cheese rather than just strings. Did you get what you needed from that? Were you able to follow along, or did you see how that worked for everybody? Unless it's just you. Does anybody, do you want me to step through this? Well, if anybody else needs it. Yeah, that'll work. Yeah, cool. All right, so that's all I have then, and we'll link up and go over it then.